Welcome back. The next problem we're going to look at is one of these problems that involves this relationship. Distance equals rate times time. So let's see what we can figure out. Tyrone leaves city A on a moped, traveling toward city B. So here's city A, here's city B, at 21 miles per hour. So Tyrone, his rate is 21 miles per hour. Tina, on the other hand, leaves city B and travels towards city A at 15 miles per hour. So her rate is 15 miles per hour. Now, the distance between the two cities is 126 miles. What do we want to know? How long does it take before they meet? So we have to really understand what this means. How long? Well, how long will they be pedaling? The key is T is going to be the same for both. Now think about that for a minute. They will travel different distances. Obviously, Tyrone is going to travel a little further than Tina when they meet, but they're going to meet at some point, and at that time, they will have both traveled the same amount of time. So let's see what we can do with that. For Tyrone, how far does he travel? His distance is going to be rate times time, 21 times t. And Tina, her distance is going to be 15 times t. Now here is another key. What do we know if we add up these two distances, which are different? We could call this one distance 1 and this distance 2. But whatever they are, see, Tina travels this far, distance 2, and Tyrone travels further because he's going faster, distance 1. When we add them up, that equals 126 miles. So that means I can take 21t and add it to 15 times t, and that has to equal 126 miles. Let's get some more room here and see what we can do. The distance, we know if we take 21 times t, that's the distance that Tyrone travels, and add that to 15 times t, that's the distance that Tina travels. This equals the total distance, 126. Now we have an equation to solve, and let's do it. What's 21t plus 15t? That's just 36. T equals 126. Now you know how to solve for t. We're going to divide by 36. And t equals 3.5 hours. So they each pedaled or rode for 3.5 hours. So this problem can look really hard, but the key is to remember they traveled the same time. And if you set up the distance equals rate times time for each one of them, you know that you add those two distances together, it's going to be 126. So I hope you'll be able to do this problem. Okie doke. Another rectangle. Let's go ahead and draw ourselves a rectangle. Okie dokie. The perimeter of a rectangle is 40 inches. I'm going to call this the width and this the length. We already know perimeter formula is 2 times the width plus 2 times the length. If you don't remember where that comes from, you get the perimeter by adding up all the sides, right? And so we know that 40 equals 2w plus 2l. And what can we do with this equation? We can divide everything by 2. So 20 equals w plus l. So that's just, I just stopped and took this first sentence or part of the sentence and said, what does that mean? Now, the other information we have is about area. Area equals length times width. And we know that 84 equals the length times the width. So what are we going to do? We want to find the width and the length. Well, we have two equations here. The easiest thing to do is to say, use this equation. If 20 equals W plus L, then what is L? Well, isn't L going to be 20 minus W? I just subtracted W from both sides. And yes, I changed the order. So now how does this help me? I can plug that into here. So 84 equals W times 20 minus W. Now we have an equation that we know how to solve. So let's see what we can do with this. 84 equals 20W minus W squared. This is a quadratic equation. I'm hoping that we'll be able to factor. That's going to be my first plan of attack. But first I need to get it set up in standard form. That means all the terms on the left-hand side and 0 on the right-hand side. Get some more room. So how do I get this into standard form? What you have to do is just be careful. Now I want to get this W squared on the other side, so add W squared to both sides. So now I have W squared plus 84 equals 20W. Now subtract 20W from both sides. And we have W squared equals, my bad, W squared plus 84 minus 20W equals 0. This is not standard form yet. Standard form, we have to rearrange. W squared minus 20W plus 84 equals 0. Now, can we solve this equation? That's the question. Let's try. So if it factors, we're going to have W, two factors, right? Both have W and W. Notice that this is negative and this is positive. So we're going to have a minus sign here and a minus sign here. Now, what are we looking for? We're looking for factors of 84 that we can use. So we want A times B to equal 84, and we want A plus B to equal negative 20. So this is how I start doing this. Factors of 84. Well, 2 divides 84. That would be 2 times 42. That doesn't work, right? 3 divides 84. And you could just check with your calculator what numbers divide 84, but I know that 8 plus 4 is 12. 12 is divisible by 3, so 84 is divisible by 3. Now 3 and 28, I cannot use those two numbers to get negative 20. 4 divides 84, 4 times 21. That doesn't work either, so I'm going to keep going. 6 divides 84. I know 5 doesn't. 6 divides 84, and we have 14. And then my eyes light up. I say, I can use those two numbers, negative 6, negative 14, to get what I want. So I have W minus 6 and W minus 14. Okay, so what does that tell me? That means W equals 6 or W equals 14. Now, this is the little confusing part because these are our answers. This is 6, and L is 20 minus 6, so L equals 14. So once you've factored it and got those answers, those will be your answers. And you might say, what if I'd chosen this for my width? Well, that's fine. If you said W equals 14, then L equals 20 minus 14, and L equals 6. So that's just sort of an orientation problem. And back here at the beginning, you could have taken this and said W equals 20 minus L. It doesn't matter which one you solve for. You will still get the right answer. But the key is to be able to go from here to either this equation involving the relationship between L and W or this one. Either one will work. Okay, I'm going to pause here so we can take a break and start this one fresh.